Hello, hello, fellow nerds. We're here today on the Mind Snacks podcast to talk to you about how your brains work, how they work, and how us electronic wizards intend to start utilizing their processing powers to create ANNs, or also known as artificial neural networks. I have a co-host with me today. Her name's Elizabeth Carter, a brain trauma nurse at the IU Health Neuroscience Center. Liz, hello. Is that your correct title?
Hi, no, actually, I am neuro research nurse, and I specialize in the development of testing to learn more about the spatial mapping of brains leading to memory loss. Thanks for having me.
Cool. All right, so since you know all about our mere mortal human brains work, how familiar are with what a CPU is?
Like a computer?
Sort of like a computer, yes. A CPU is a central processing unit. It's not that much different than the human brain. The CPU in your computer, for example, takes inputs from sensors, does math with them, and other things to do complex algorithms, diagnostics, anything that us humans can program them. For instance, PLC takes in programmable logic, ladder logic, and it can take in sensor input. So what the CPU generally lacks is the neurons that the brain has to establish thinking and memory, which you're familiar with as a neuroscience. What was it again?
A neuro research nurse. But brains are far more complicated than that. The hippocampus, for example, is just part of the brain that my work primarily focuses on. Here, that is how we associate memory and navigation to recall how to drive home, for example.
A hippo to help you drive home?
Not exactly. But the visual system processes the traffic in the surroundings. The auditory system processes car horns and sirens. The motor neurons control the hands to keep it on the steering wheel while also holding a cup of coffee.
My cup of coffee while I'm driving, one of my favorite things to have. Usually I spill it on the way to work. All right, so, all I hear when you say auditory system and traffic system and visual systems, I'm just hearing I/O. So in computer logic, that's input, output. So for my CPU to learn to drive, all I need to really do is recreate this hippocampus. So I'd start with the most important part, the visual system. There's several options here: LiDAR, forward-looking infrared, distance imaging software. But replacing how the eyes process information, I think, is a real process for us to recreate. How advanced is the eye processing in the brain? Pretty advanced? Just give me an odd look. All right, so let's talk enough about cars and them learning to drive. I know that's super cool, but let's talk about something that occurs today, right now, with artificial neural networks. I think one of the most profitable things that happens today is art. Recently, some engineers in Germany took pre-trained neural network, and then they taught this machine to combine pairs of images from a famous painting, Picasso in this example. So they took every Picasso ever made, every painting that he ever did, scanned them in, and let this computer mathematically map out how he did this. And then this allowed that artificial neural network to take users' paintings and pictures of their own, maybe it was of their children, and this ANN would recreate it as a Picasso. Super cool how to do it. Do we understand how some humans have this ability and others don't have that ability, such as art and music?
No, we don't really have a complex understanding of how the brain functions and why some of us can master things like paintings and arts and music. All of that is not well known. Perhaps there will be a bridge here where the artificial networks teach us how the real ones behave.
Yeah, that's cool. Yeah. So, one thing I'm fearful of for AI, people think AI might take over. I'm more fearful of a fake painting. You maybe couldn't distinguish the fake one from a real one. Start doing money laundering. It's pretty ingenious thing, right?
Yeah, now I'm wondering if the art I just bought is fake.
Probably is. It's probably these German engineers. All right, so enough about the art and the cars. Let's talk about voice and speech recognition. Would you believe me if I told you that Siri had a brain?
Yes. Siri, do you have a brain?
Yeah. See, I think you see where I'm going, right? She didn't really hear you there, but sometimes she can recall and remember your certain voice. I think that's how her ANN is distinguishing who's who. So your kids can't say, "Hey Siri," or I can't say, "Hey Siri," to get your phone to turn on. She does have a small brain. She operates on a small artificial neural network, but go full scale with this technology, you can iterate over and over thousands, billions, millions, and millions of words, right? Thus creating deep fakes like Val Kilmer in Maverick.
Wait, that's fake?
Yes, that's totally fake. Val Kilmer lost his voice due to throat cancer. So to recreate him, they taught an AI with an artificial neural network to speak just like him by listening to every word he ever recorded in movies.
That's pretty cool. I suppose that's how others that do impressions learn. They listen, store, and repeat, making that hippocampus larger and larger.
Here we go back to that hippocampus. That's a pretty cool thing. So, Liz, I have one last question for you before we have to go here today. Are you scared of a machine that can replicate a human?
There will certainly be pitfalls with any new technology. However, I see this as a way to help us understand the mind more. Perhaps we can learn more about various brain ailments such as memory loss and turn it off with an embedded artificial neural network.
There we go. Yeah, we can turn off the short-term memory loss. Great point. I think this is where science and us nerds can join alliances and put an end to where we forgot to put our car keys. But that's all we have for today on this podcast. Tune in next week and we're going to talk about how the summer's over and the fall semester begins. Thanks. See you then.